0. Okay, so getting ready. Pre-lab for week 2. Well, some people are, well, let's see, Tuesday, but that's all right. That's why this thing has make-believe data in it. So people who already have data, the smart thing to do would be to plug in your numbers. Notice that this goes from 1 to 100,000, and we don't have that many, but it's just a generic set of data I've created. And your V-ins are not all going to be the same. So again, because this is make-believe data, they're all the same. So make sure again, I would put my own data in here at this point, instead of working with what's in this template. People who don't have data yet, the Tuesday group, all you have to do once we're done here is type in your data, and then everything will be all right. The graphs will already be made and all that, but as a pre-lab, it's just about getting ready. Okay, so we've got our V outs, our V ins, our frequencies, and you remembered to, let's see, zoom to selection. You remembered to write down your L and C values and the resistance you used. It might be 10, it might be 100. This, I don't recall, this is 8 millihenries, so that's 0.008, or to do exponents, so 8e minus 9, and then, minus 3, forgive me, 1, 2, 3, 4, 5, 6, and then most people had about 950 nanofarads, so 950 E minus 9, and that's 0.9 microfarads. Okay, so the first thing we need to create is V out divided by V in, and oops. Well, I suppose one could get rid of the underscore. We know what that is, and I certainly want to keep the nomenclature going, because it makes you. And I remind you, this is when you have it set up like this. They call it an RC circuit. And that was circuit 1. And then we need over here the 20 log V out divided by V in RC. And we can deal with this now by just going like this. And then we want to, let's see, where's the format? It's probably, I'm sorry, staring at it and I don't see it. We'll start here. Wrap text, and then center it vertically and horizontally. And wow, V, there we go. Okay. And then also we want to put here this circuit is how we measure the reactance of the capacitor. Okay. We've got to derive a formula for that. So this equals V out divided by V in, and then 20 times log, oh, I forgot to put equal sign again, equals 20 times log, and we want log base 10. Oh, I thought it would fill it in for me. Log 10, and then open parentheses. Oh, it's this number. And close parentheses. And then we can fill. There we go. And we can make these look pretty. I don't know if it's number or scientific looks best. Let's see. Yeah, I like that. And then, okay, how do we get the react? Well, I guess we could call this Z of C for now. It makes it a little easier to understand. So refer to our circuit there. And oh, I know what to do. Let's cut, and we can paste it as a picture. Make it a little smaller. Okay, so we've seen this 100,000 million times. Ooh, that's a little big. Let's see, there we go. V out over V in equals, so Z2 over Z1, Z2 over Z1 plus Z2, and of course this is R and this is C, and so we can cross multiply Z1 V0 plus Z2 V0 equals Z2 V in, and then we can write this as Z2 V in minus V out. So we brought this over here, and that equals then Z1 over V out, and then so Z2 equals Z1 V out over V in minus V out. Let's double check myself here. Yeah, so I brought that over here. That becomes minus Z2 V out. And then V in minus V out. This just stays, doesn't change sign. Okay, so Z1 is the resistor. So now you see why we needed to write down all the values. And, oh, something didn't go. Let's get everybody. There we go. Well, mostly just, well, we'll see if we're going to extract the value of the label value. Okay, so this equals to let's see, equals the resistor. We need dollar signs times V out divided by, we'll close parentheses, V in minus, excuse me, V out. There we go. And then this is in ohms, by the way. I forgot some things here. Ohms. This is dBs. Okay, let's see here. Let's make this a little bigger. Okay, so then we can do that. And let's see, we'll box it in. And right mouse click, all borders. Okay. So now we want to graph something. We have two graphs for this sheet. Let's zoom it out. Yep. Okay. And so we want the frequency, and hold down the control key, and we want this. Now this is when this graph now, because this, whenever we deal with frequencies, we're going to pick the smooth line, no points. And so this is almost a Bode plot. We got to format the make it its logarithm on the left. Now we're going to make it on the y-axis, make it logarithm on the x-axis. And there is your Bode plot. And notice that it passes till about like 800, 900. We have to see if we can figure, well, the 3 dB point is, here it is, right here, minus 3.03, and it's close enough to government work. So at 700 ohms, 700 hertz, this thing is now cutting off the input. Now for this, we also want now the frequency, excuse me, and the impedance of the capacitor, and then we insert, and once again we have this guy, and that sure doesn't look like much, but what we can do is we can make this logarithmic. So you see that the capacitor is a frequency dependent variable resistor, and we can make this logarithmic, and that's pretty cool, isn't it? It's a straight line, so you can actually do a fit of that and extract the value of the capacitance. But anyway, for now though, this is what the pre-lab is, to set up the table, make these two graphs for the RC, for the CR. So this is the, so if we say CR, we mean this, out, in. So now we need to do this, V out or V in, and these two guys. Hint, hint. Watch this. Copy. And I want to paste. No, I want to paste. Not paste numbers. Just paste this. And oh, look at that! It noticed it formatted for us. And center, and wrap. Yeah, I want to wrap text. Now you have to change this to CR. And CR. And of course you want to make it, yeah, see there it does it, right? And now once again, this guy, and what is it? Oh yeah, insert. So the hardest part is just the beginning. And so now, so this is interesting. Look at that, huh? This is now called a high pass filter. And again, don't forget to change the labels there, because this says RC, right? It needs to say CR. And you can actually get away. Now this is one where we want to do the impedance of it, because this is so this is the RL. Feature bloat. Out. In. And this time we can actually do this. And copy. And here. Paste. And remember that you're pasting everything. And then we can tweak that a little bit. And now you make another graph. And then this one here, we just remember that we don't need this one. In fact, what would this do for us? No, okay, no, that's not right. So we'd have to, so we need to just make sure and get rid of that. So every one of the tabs needs a Bodhi plot. And then the RC and the RL also need the impedance plot. All right, this guy here. And again, don't forget to tweak the labels up above. And so you'll submit this spreadsheet as your pre-lab. And for people from Monday and Wednesday, of course, I would highly recommend is you type in your own numbers there. Okie dokie. See you soon.